Welcome to Curve Sketching Possible Graphs Part 3. I typed a lot of this, and I'm sure the type part's in your notes. I'm pretty sure. So we're just going to add to it, you're just going to add to it the other parts that aren't typed. And all they are is the sign charts, the explanations, things like that, and how we know, and et cetera, et cetera. Let's read the bottom part, so try not to look over to the side. I'm done with moving the screen on camera. It didn't want to be very nice to me in the last video. All right, so we have x equals -2 is a vertical asymptote. Well, we should graph that. That's a pretty easy thing to do, isn't it? Yes, that is. So x equals -2, vertical asymptote. I'm graphing red. All right, well, you would think, there it goes, except up here. All right, x equals -2 is a vertical asymptote. Y equals 3 is a horizontal asymptote. That was told to us. So that we know. Oops, well, got a little glitch in the board. I'll try and compensate for the glitch. Good enough. You can do yours a little better. And I'm actually going to put x equals -2, y equals 3, so that there's no confusion over my wavy line there. I guess I could have used a line tool, but it's okay. All right, so we have, let's look at our information here. That's the only information we have about the function, and then we have information about the first derivative and the second derivative for us to interpret. So f of 2 equals 0. All right, so that means that x equals 2 is a possible extrema. All right, so x equals 2 is a critical point for the first derivative. All right, so the 2 one here, that's for the first derivative. Right? So that's a critical point. It could be an extrema. Right? We have to check the sign chart. Is it increasing and then decreasing, or decreasing and then increasing? Is there a change there? All right, so now let's look what else it says about the first derivative. So right here in the, that's for the blue. This was in green. I wrote it in green. All right, so for the first derivative, f prime of x is greater than 0 if x is less than -2, or between -2 and 2. All right, so if the first derivative is greater than 0, that means the function is increasing. And f prime of x is less than 0 if x is greater than 2. So first derivative is negative, then the graph f of x is decreasing. All right, so we have from -infinity to -2, the function is increasing, specifically f of x. I'm going to just write f of x over where I say function. I really don't use function, use f of x. They're kind of a stickler sometimes because they're all functions. First derivative is a function, second derivative is a function. All right, so me bad there putting a function. Let's put f of x. So if it's in your notes, just put a little f of x above all of those. Right, so here when I say function, referring to f of x. Now, if you write function and then you put in parentheses f of x, that's okay. But when we say function, we mean f of x here. All right, so f of x is increasing from -infinity to -2, and that's because the first derivative is greater than 0 for values less than -2, and then between -2 and 2. Right? So because it's increasing, therefore, -infinity to -2 and -2 to 2. Both of those are increasing. And then function is decreasing from 2 to infinity. That's because the first derivative is less than 0 if x is greater than 2. All right, so that from the second derivative, we have a critical point at x equals 4. Right, because the second derivative equals 0 there. Could be an inflection point. We have to look and see if it changes sign. All right, so before we do that, though, let's look at the sign chart. And the sign chart is right here in the notes. So let's look at the sign chart for the first derivative. I give myself much space there, so it's kind of plucked down in there. And then we'll come back to look at concavity. So there's our first derivative sign chart. 2 was the only critical point. For values less than 2, we're increasing, graph is positive. For values greater than 2, graph is negative. So that's a relative maximum because f prime of x is increasing for x less than negative 2 and that is like the most wordy sentence ever. I'm going to write that nicer. Let's put a little star there and write that nicer. That is wordy. All right, so x equals 2 is a relative, actually I should say f of x has a relative max. F of x has a relative max. That's what happens when I type it. Sometimes it can be wordy. At x equals 2 because f prime of x changes sign from positive to negative at x equals 2. Much cleaner there. That's what I get when I'm writing it. All right, so that's our relative max. Let's just put that in there. All right, so that's clear because that was wordy when I typed that. All right, now let's look at the concavity. All right, so it says f double prime, so we're looking here. F double prime of x is greater than 0 if x is less than negative 2 or x is greater than 4. And so the second derivative is less than 0 if x is between negative 2 and 4. All right, so we're changing concavity. Concave up from negative infinity to negative 2 and from 4 to infinity. Concave down between negative 2 and 4. So second derivative sign chart there is in red right here. All right, so we go from negative to positive at 4. At x equals 4 is an inflection point. There's a change in concavity. Let's add a little something to that. So f of x, let's make sure that's clear. F of x has an inflection point. I may change my typing to change the notes then. An inflection point at x equals 4 because f double prime of x changes, that's mostly in there, sign at x equals 4. It doesn't really matter whether it changed from positive to negative, negative to positive. It changed sign. That's all that's needed for an inflection point. All right, let's see if we can draw this thing. All right, so remember we can't cross the vertical. We're not going to cross the vertical or horizontal asymptotes. A function could cross the horizontal asymptote, but we're not gonna. And it doesn't tend to cross them when there's only one vertical asymptote, but and let's try not to. So let's look at the first one. So between negative infinity and negative 2, concave up, and we don't have to worry about any extrema. All we got to do is make sure it's concave up. Well, that's easy enough. Concave up. There we go. Looks good to me. Look good to you? I think so, right? So that's fine here. And we had to make sure we're increasing. So concave up and increasing. I think we managed that, right? So looks good because f prime of x is greater than 0. F double prime of x is greater than 0. So increasing and concave up. There we go. See up. All right, so that looks pretty good. Now we got to worry about the other part. We have an extreme value. So let's put our graph here in the across like catty corner. So going like a not in the not directly across, but like diagonal from one another. Let's put it in that it'll mostly be in the fourth quadrant there. And we need to worry about the extreme value at 2 and right 2, yes, and it was a relative max. So we're going to need a relative max here at 2. Doesn't matter where you put it on the y, just make sure it's at 2 on the x. So I'm just going to put a horizontal tangent line there because I'm going to shoot for that. to get right there. If I have something to aim for, sometimes I'm better at making sure it's a relative max. And then concave, where are we concave down? Concave down from -2 to 4, and then we got to be concave up. All right, we can do this. We can do this. All right, so concave down, good. Hitting that right there, I've got that tangent line, and now we're gonna, and we got to make sure we change concavity at 4. So try to aim for 4 to have it start being concave up, right? So it's kind of like that. So, nope. We're not changing concavity at 4 there. Let's try that again. Now I'm changing concavity at 3.5. So you see what I mean? Sometimes it takes a few times. Let's make that, oh, my goodness. Let me see if I can do that one smooth motion. There goes my horizontal tangent line. So you don't have the problem of trying to figure out where the pen, there we go. If I just am way off on the pen and I want, my goodness, all I got to do is get that inflection point in the right spot. Maybe if I make so I want it to be something like that, where we're changing right there. Now my horizontal, now of course dude, how long will it take? Okay. Now all I got to do is get the inflection point in the right spot. I'll take that. That doesn't look too bad at all. All right, so inflection point only took me 6 tries. So you can see, you can know in your head what you want it to be, and you got to draw it, especially on a smartboard, and it doesn't happen. So right here, I'll put it in green. This was the inflection point. Graph is concave down here, and it's concave up there. We've got right here, I'll put this in red, or not red because I already used red. How about black? I don't want it to look like, get mixed in with the horizontal tangent, or horizontal asymptote there. We have a relative max there at x equals 2. Looks good. I think we've got everything in here. All right, so just, go through each part when you're drawing these on a possible graph. Go through the value, the values you're given for the function, the information you're given for the function itself. Use the information you get for the first derivative, and then use the information you got from the second derivative to make sure the concavity is correct and inflection points are correct. So this one is done. And in the next video, we'll look at a little bit more curve sketching, but that's it for this video. Bye for now.